Hello again and welcome to our next training movie. Now we will show you the graphical system and load generation with SOFiPLUS X. To start the graphical pre-processing, double-click on GUI for model creation. Program SOFiPLUS X opens and a DWG file with the corresponding project name is created. We highly recommend to first draw the geometry with AutoCAD elements and creating the structure elements afterwards. If you are dealing with a complex structure, it might be time-saving to draw a freehand sketch first for defining the structure model and then hand it to a draftsman to implement it in AutoCAD. On the one hand, draftsman can usually draw faster, on the other hand you have to decide about simplifications first of all. The geometry of our slab is very simple and can be entered quickly. Draw a rectangle through the origin with a length of 20 meter and a width of 10 meter. The rectangle should now be divided by a center line into two squares. This is pretty easy if you have activated midpoint as option of object snap. The left square again has to be divided into halves with a line in X direction. Now the geometry input is done and you can start to define the structure elements. Go to the sidebar and select the tab Structural Elements. First let's define the structure areas. The thickness of the area has to be increased to 240 mm. If you now make a right click in the workspace, you can choose between different options on how to define the area. The easiest way for our structure is point in area. Now click into the first area top left. A dialog box for load definition opens. In a 2D slab system, each structure area is automatically associated with two load cases. Load case 1 for permanent load and another load case for imposed load. The load case number for the imposed loads will be auto-incremented. There is a permanent load of 1 kN per square meter and an imposed load of 3 kN per square meter on our structure. If you check the box Show Dialog once only, you can define loads easily and change them afterwards if necessary. When you now click OK, the program automatically identifies the boundaries of the area and area number 1 with load cases 1 and 2 is created. The command point in area is still active. Thus you just have to click into the next rectangle to create area 2 and again for area 3. When done with the input of the structure areas, you can close the dialog box. To control your input, you should export your system once in a while. Click onto the export icon. There are no changes necessary, thus we can confirm the dialog with OK. On the tab Messages, the sidebar shows you information about the export. If there are error messages or warnings, make a right click on the message to zoom to the elements with trouble. When the export is completed, you can check your system with the animator in SSD. If you go to tab, Loads, and open the Load Case Manager, you can see that there are 2 actions and 4 load cases defined. For load case 1 we are going to set the factor of dead weight to 1.0. Thus the program will calculate the load from self-weight all by itself. The permanent load you assigned to the structure elements should only contain additional loads, and general from floor construction. To check or change the loads you defined with the structure areas, select the command, Modify Structure Area, and click on the desired area. Next, the supports and the downstand beam will be created. Due to the concept of SOFiMSHC, the structure lines are completely independent of the structure areas. They have to be defined additionally with the command line. Go to tab, Support Conditions, and check the box PZZ for global Z direction. There are again different options to define the line. The T-beam is in between area 1 and 2. Open command line again. Go to tab beam/cable and select centric beam. Assign the cross-section number 1 that we defined earlier to the beam. With the option, pick line, you can model the downstand beam. In a final step we will model the 3 columns. Select the command, point, in the sidebar. Go to tab, lower upper column. The columns should be modeled as elastic springs. The diameter of the columns is 300 mm. Material 1, concrete is correct. Only the length of the column, which is 3 meters, has to be entered. If you now move your mouse into the drawing area, you can enter the coordinates for the columns. Now the system generation is completely done and you can export all elements. Then you can shut down SOFiPLUS. Don't forget to save your drawing, because this is not done automatically with the export. Having said that, saving the drawing will not export and write data to the database. Here is your completed slab. In this movie, we showed you the graphical workflow for system and load generation in SOFiPLUS. The system was defined using structural elements like areas, lines, and points. The loads were defined as element-related and free loads. Thank you for watching this tutorial movie.